In the previous video, we answered the question, how does the router know which route to put in the routing table if it's learned that route from multiple sources? And the answer is that router gets up pretty early in the morning, or the AM, to figure that out. And AM is an acronym for administrative distance. It's like golf. The lowest one wins. And if that's a tie, meaning we have two or more routes with the same exact administrative distance, it then takes a look at the metric, or the cost. And then the lowest cost, that route will be put in the routing table. And if we have two equal cost routes, it can go ahead and load balance over both of those. So we're going to reinforce those concepts by using a hands-on lab and manipulating some routes in the routing table so we can see the changes right in front of our eyes. So to demonstrate this, let's use this topology, and we are going to use the 10.x network for all of this with a 24-bit mask. And as a reminder from our previous skills, that x represents the two numbers. So this between R1 and R2 would be 10.12.0.0, and between R3 and R4 would be 10.34.0.0. Between R2 and R3, that would be network 23, 10.23.0.0, and 1 and 3 would be 13, and 2 and 4 would be 24. I think we got it all. Also, on the edges of the networks, we have 10 dot and then the router number. So this would be 10.2, this would be 10.1, this would be 10.4, and this would be 10.3, followed by a couple more zeros and a /24. So let's take a look at the AD process first. Again, the lowest administrative distance for a given route is going to be used and put in the routing table. So the route on the network I'd like us to focus on for this first exercise is 10.2.0.0/24, which is this network over here hanging off of R2. And I'd like to look at that route for the 10.2.0 network from the perspective of R3. So I'll put a check right there indicating we are going to be right here at R3 looking at the route for the 10.2.0 network. And this is a hands-on lab, so click on the link for the virtual lab, and let's go ahead and look at this routing table together. Bop, 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 bop. I'm just waiting for the lab to load. This is going to take one more minute. So we're here on DCNUG. Let's go ahead and open up the topology real quick, so if we need to refer to it, we can. Fantastic. And then we'll open up MT-PuTTY up in the upper left-hand corner, and then we'll open up consoles to R1, R2, R3, and R4. And we'll start on router 3. And on router 3, we'll do show IP route. And instead of looking at everything, we can just go ahead and put show IP route, and we can put 10.0.0.0, and that'll just show us the routing output for all the 10 networks. And then if we focus in on the network in question, which is the 10.2.0 network, it is right here. So on the far left, that's the routing protocol code of O, meaning it was learned via OSPF. Here is the network, 10.2.0 with the 24-bit mask. Next, we have the administrative distance, which is 110, which is the default AD for OSPF. And then after that, we have the metric for OSPF, which is cost, and it has a cost of 3. Shows the next hop of 10.13.0.1. It also shows the egress or exit interface that this router, R3, is going to use when it forwards a packet towards the 10.2.0 network. So as we're focusing right here on administrative distance, I have a question for you that I'd like you to consider with me. If we were going to replace this route with a better one that had a better administrative distance, what administrative distance could we use that would be better than the administrative distance that this route currently has? Now, if you're saying, Keith, I see here that the administrative distance is currently 110. So for this exact network, 10.2.0 with the 24-bit mask, if we had a route that was learned or configured and it had an AD, an administrative distance of less than 110, which would include 109, 108, 107, etc., then that route with a better or lower administrative distance would be put in the routing table. And this one that we are looking at right now would no longer be used if there was a better route. So here's what I propose we do. Let's add a static route right here on R3 that says to get to the 10.2.0 network with the 24-bit mask, go ahead and use the next hop of, and we'll take a look at our topology and decide on what we want that next hop to be. And we'll use an administrative distance of something less than 110. So for a static route, the default AD, the default administrative distance is 1, but we can tack on another number, and I think we should. And for the demo in the lab, let's go ahead and do this. Let's go ahead and set up an administrative distance of 109. Because 1 is certainly lower than 110, but 109 will be very visible as it shows up in the static route that we're about to create. And that will supersede the current route that's there. And so the existing route that's there right now, it'll be gone. So let's take a look from R3's perspective at the next topic we can use. This is the 10.23 network, and R2 is up here at .2. So we could actually specify 10.23.0.2 as the next hop for our static route getting to 10.2.0.0/24. And actually, before we implement the static route, let me show you a really cool command that I love that can show us, hey, Mr. Router, based on this destination IP address, which route are you using? It'll tell us. Check this out. If we do a show IP route, and we can follow that up with the name of the routing protocol or the keyword static or the keyword connected, but we can also put in an IP address. So I'm going to hit Q, and let's do a show IP route for 10.2.0.2. That's the IP address way up there hanging off of R2. And if we press enter, this is, I'm giddy. It shows us which route in the routing table matched. It was the route for 10.2.0, the 24-bit mask. That's the route that matched. Here's the administrative distance. Here's the metric. In OSPF's case, it would be cost. And it's fantastic. So let's go ahead and do a show IP route again for the 10 network. And there's our current route. And let's go ahead and replace it. So we'll do an IP route, space, and then we're going to put in that network, 10.2.0.0 with a 24-bit mask, space, and then the next hop we decided we're going to use is 10.23.0.2, which is R2's address across that serial link, space, and just for grins, let's put in an administrative distance other than the default of 1 for a static route. Let's use 109 because that's enough to beat the current existing route that has the AD of 110. And we'll press enter. Then we can do a do show IP route for the 10 network. And check this out. Now for the 10.2 network, it is a static route that is 1. There's our administrative distance, and that's the reason it won. It has a better administrative distance. And now if we do a do show IP route for that target of 10.2.0.2, check this out. It's going to show us the routing entry that matched. It indicates it's a static route. There's the administrative distance, which is why it won over the other one that was learned via OSPF. And if you do a ping, that also implies that the other routers in the network are cooperating, and they also have a path back to R3 for the reply to those ping messages. So in this video in lab, we've had the opportunity to watch the router prefer a route with a lower administrative distance for a given network. We did it by creating a static route that had a better, lower administrative distance than an existing route, and as a result, it got preferred and put into the routing table on the Cisco router. Now, check this out. There's another tiebreaker involved. If we have 2 or 3 routes that are being advertised and they all have the same administrative distance for the same exact network, the next tiebreaker is cost, or the metric. We'll take a look at that in the lab in our very next video. So I'll see you there in just a few moments. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.